Okay, here we have our same circuit, and I've taken away two of the meters, and I'm just showing you the output voltage here developed across that resistor that was connected to our collector. Here's our circuit. This is called the common collector circuit, where the transistor sits between the output and 6 volts. It's also called an emitter follower because the output is taken following the emitter. We'll talk more about the meaning of that later on. But what's going to happen with this circuit? I've got the 10K resistor, so we know that this is a circuit that's going to be operating in saturation. When I shine some light on it, the transistor is going to turn on, and it'll be saturated, so that I'll have all my output voltage developed across this resistor. So when I have light shining on it, I should have a high output voltage at V out. And when I do not have light shining on it, or that is when it's dark there, then I should have V out being low. Okay, so right now we have V out at 0.23 volts. That's just due to the ambient light in the room. Turn on my flashlight, and we can see that the output jumps to 6.35, so the output is high. So output goes low, output goes high. And I may even be able to use my hand to break the light beam to bring the output voltage low. Okay. And now I've reconfigured the circuit to give us the common emitter circuit. And here you can see that I'm taking the output voltage between one terminal of the resistor and the collector. So I've moved that resistor up. Here at this node, I'm taking the output voltage relative to ground. That means I'm taking the output across the collector emitter terminals of the transistor. So where before I was taking the output across the resistor, now I'm looking at the output across the transistor itself. And so this will behave as the inverse of the previous circuit. When I shine light on the transistor will be on, and when the transistor is on, I have a lot of current flowing through it, so that current will flow through the 10K resistor. All the voltage will be dropped across the 10K resistor, and very little voltage is dropped across the transistor. So when I turn this on, V out will be 0. And when I turn the transistor off, V out will be high. So let's take a look. So here you can see that the output voltage is high. We're just looking at the ambient light in the room. It's not enough to turn on the transistor. I use my flashlight and I turn it on, and you see the output voltage goes low. Okay, so the transistor, right now the transistor is on, and when that transistor is on, all of my current is flowing through that 10K resistor, so all the voltage is being dropped across there, and very little voltage is dropped across the transistor itself, so the output is low. Okay, I take away the light, turn off the transistor. When I turn off the transistor, there's no current flowing through it, so there's no voltage drop